so I think we're ready for example 4. Are you in the same place I am? All right, so let's take a look at what's going on here. Another multiple choice question, and it looks like it's about maximums and minimums. So this is another situation where, I don't know, when I think of maximums, I think of tops of hills, and minimums are bottoms of valleys. So I like to consider my graph rectangularly. You don't have to. You can do it polarly if you want. But because it's easier for me, and we need the review of how to graph rectangularly, I'm going to take my equation, y equals 1 minus 2 sine 2x, and I'm going to graph it rectangularly. So that's negative 2 sine 2x plus 1, which means I have a midline at 1. I have an amplitude of 2, so I'm going to go up 2, so that'd be like 3, and negative 1. And it's negative, so remember signs start at the origin, but it's going to come down first. Would everyone agree with that? Now, normally, this label would be 2 pi because that's the period for a sign. But what does that guy do? Divides by 2. So this is just pi. This one is pi over 2. This one is pi over 4. And this one is 3 pi over 4. Does that make sense to everybody? Okay. Now, the downside of doing this is when you've been lifted, these numbers right here are important. And they aren't these because it's been changed. So we want to know where that guy is going to equal 0. So negative 2 sine 2x plus 1 has to equal 0. So negative 2 sine 2x equals negative 1. And sine 2x equals 1/2. Where does the sine equal 1/2? At pi over 6, or 5 pi over 6. So the angle, that angle right there has to be pi over 6, which means x is pi over 12. So this guy right here is pi over 12, and this guy right here would be 5 pi over 12. All right, let's see what's going on. On the interval from pi over 3, all right, well, pi over 3 would be in here. This is getting really messy, but I'm going to put pi over 3 would be here, and 2 pi over 3 would be here. So on the interval from pi over 3 to 2 pi over 3, we change from negative to positive. So from pi over 3 to 2 pi over 3, does the curve change from positive to negative? Or excuse me, negative to positive? But changing from negative to positive, that doesn't make a minimum or a maximum. That makes a 0, doesn't it? Look, the question is saying there's a minimum on that interval. No, there isn't a minimum on that interval because minimums aren't formed by going from negative to positive. How are minimums formed? From going decreasing to increasing. So A is wrong. A isn't true. B, from 2 pi over 3 to pi, so right here, this from here to here, not part of the graph. We change from decreasing to increasing. No, we don't. We change from increasing to decreasing. So that would be a maximum, but it says it's a minimum, so that's wrong. B is false. C, from pi over 3 to 2 pi over 3. So from here to here, we're changing from positive to negative. Well, actually, we're changing from negative to positive, and that doesn't have anything to do with a maximum or minimum, so that one's wrong. I hope D is right. From 2 pi over 3 to pi, we're changing from increasing to decreasing, and that means we have a maximum, so that is true. That is true. Okay. And then, we got a couple on the back, I guess. All right. So then we got example 5. I'm finding the average rate of change, so I don't think I need a picture. Who remembers how we find an average rate of change? It's like a mega topic in Unit 1.
Like y2 minus y1
So using our notation, if our interval is pi over 2 to pi, then it will be f of pi minus f of pi over 2 over pi minus pi over 2. That okay with everybody? And our equation is 3 minus 3 cosine. Okay, this doesn't seem like this should be too bad. So f of pi, let's put pi in there. What do we get when we put pi in there in that equation? Plug in pi. What do we get?
Say 6.
We get 6. 3 minus negative 3. So we got 6. What do we get if we put in pi over 2?
3.
Because the cosine of pi over 2 is 0, so we get 3. And then pi minus pi over 2 will just be pi over 2. So we have 3 over pi over 2. Did you get 6 over pi? And remember, very often, not in this problem because there's no discussion of units at all, but very often, average rates of change are going to have a unit. Inches per minute, or something like that. This one doesn't. All right, that seems pretty easy. All right, so example 6. Picture's already drawn, that's good. At least polarly. Okay, anybody have an idea here? Here's our equation. And we're looking at the interval from pi over 4 to 3 pi over 4. Let's just start there. We want to know, is the average rate of change on that interval equal to 0? Right? If the average rate of change equals 0, don't these two have to be the same thing? So in other words, wouldn't f of pi over 4 have to be the same as f of 3 pi over 4? Right? That would make it 0. So let's see, if we put in pi over 4 up there, we're going to have 3 sine pi over 2. What's 3 sine pi over 2? 3. And if we put in 3 pi over 4, we're going to have 3 sine 3 pi over 2. That is negative 3. Now, if you do the average rate of change with those two numbers, are you going to get 0?
Yeah.
No. No. You subtract.
Okay.
Number to subtract. The only way the average rate of change will be 0 is if these values are the same. All right? So let's see. Go ahead. Try B and C and D and see if any of them turn out to be the same. I did not get B to be the same. Oh. Did you get C to be the same? I think it's C. Because I already did 3 pi over 4 and got negative 3. When I put in 7 pi over 4, that gives me 7 pi over 2. And 7 pi over 2 is the same as 3 pi over 2. So I got negative 3 for both of them. So I think it's C. You with me, guys? You see what's happening? All right, number 7. Yeah.
I have a question about number 6. Is there a way you could just figure that out by just looking at the graph?
Well, there is, but you have to be careful because, like here, like this first one right here, it looks like when I look at the pi over 4 angle and the 3 pi over 4 angle, it looks like they're in exactly the same spot. The problem is that 3 pi over 4 is actually 7 pi over 4 got plotted in a different place.
Yeah.
So you have to be careful about that.
Yeah.
Now, if we were doing it rectangularly, you absolutely can tell, because there isn't that duplication with that. Okay, number 7, all right, what's happening here? Now this one, William, because of the shape, this one you might be able to have a little more luck with that way. All right. Anybody want to take a wild guess about the average rate of change from A to B? Is 0. Because point A and point B have the same function value. So that rate of change is 0. You're looking for the least. So that one's 0. Now what's happening from B to C? What's happening to your R values in B and C? From B to C, we're going in order. From B to C, your function value, your R value, is doing what? Getting bigger? So if we're from B to C, if we're getting bigger, isn't our rate of change increasing? I mean, isn't it positive? I should say, isn't it positive? All right, it's positive. So A is, or yeah, answer A is 0. Answer B is positive. Now what's happening from C to D? 0. And what's happening from D to A? It's negative, because f of A, I'm looking at point A now. F of point A is less than f of point D. So when I do my average rate of change, I'm gonna end up with a negative answer. So which one is the least? D.
Are A and C both 0 because the points are on the same spot in the graph?
Okay, run that by me again. What now?
Like, for points A and B, their average rate of change would be 0 because they're in the same, like, part of the graph,
Right,
right?
so-
They're even.
So f of 0
Yeah,
is gonna be exactly the same as f of pi.
yeah,
So when I
Okay.
set this up,
yeah.
f of pi minus f of 0,
Mhm.
these numbers are going to be the same.
Yeah.
And so when I subtract, I get 0.
Thank you.
Same thing happens with C and D. The points are connected in order. It's not like the picture in 6 is much more complicated because it's looping around. This one is not. This one's just going around in that little limason. All right, number 8. Yeah, what's happening in number 8? The table gives values of the polar function at selected values of theta. Use the average rate of change over this interval to approximate f of 5 pi over 6. Ooh. Ooh, okay. All right, well, let's start by finding the average rate of change on the interval from pi over 6 to 7 pi over 6. So that's going to be f of 7 pi over 6 minus f of pi over 6 over. All right, now there's a lot going on in this problem, and there's a lot of words and stuff, but would you agree with that statement right there? Now, I do not know my equation. They didn't give it to me. But they did give me a chart. And from the chart, don't I know what f of 7 pi over 6 is? F of 7 pi over 6 is -1 minus f of pi over 6, which is 2. And then when I subtract these guys, I just get pi. So my average rate of change on that interval is -3 over pi. Would you agree with that? Now, when we first started all of this, way back when, we thought of average rate of change as slope. In fact, somebody earlier said y2 minus y1 over x2 minus x1. Isn't that what this is right here? So I'm wondering if we could write the equation of the line through our original 2 points, the 2 points in the chart. So the 2 points in the chart are pi over 6, 2, and 7 pi over 6, -1. To write the equation of that line, we need the slope. We've already figured that out. And what else do we need to write the equation of the line? One of the points, right? So could we say y, I'll just use that one, y minus 2 equals -3 over pi times x minus pi over 6. Can we do that? And then y minus 2 equals negative 3 over pi x minus plus, is that just 1/2? You guys still with me here? So then I'll add that 2 over, so negative 3 over pi x plus 5/2. So that is the equation of the line through those 2 points. And the purpose of the problem is to approximate a point that's in between those, 5 pi over 6. So it's not gonna be perfect, but is it gonna be an approximation? I got these two, I want the one somewhere in the middle. So what am I gonna do? Here's my equation connecting these 2 points. What am I gonna do? Put in 5 pi over 6, right here. So my approximation is gonna be negative 3 over pi times pi over 6 plus 5/2. Oh, 5 pi over 6? Is that what you were gonna say? Yeah. So it is that. Wait, did you get 0?
Yeah.
0 it is. Unless I have math mistake.
How do you get 0? Can you like?
So I put 5 pi over 6 in here for my x. And I multiplied 3 over pi times 5 over 6, and it just comes out to be negative 5/2 when I cancel everything. And then I had to add it to 5/2. We're not quite done though, we're gonna do this on the back of page, we'll do another, oh, this might be your last, check your understanding.
Oh,
We're gonna
thank
do-
goodness.
I know, what do you say, thank goodness? All right, so on the back of page 4, on the back of page 4, you and your partner work on this, on the back of page 4. Yep, and then we'll do the crack the code, and then we'll be done for today. So we're on the back of page 4. Remember, f of theta is r. Okay, those girls were working on the back of page 4. Do you have your chart filled in? These are the numbers I got. Do those look right? Because I'm gonna answer everything based on these, so I want these to be right. And those came from, I just plugged them into the equation. We had the equation given to us. Now, I could have, I didn't and I haven't yet, but I've been thinking about it. I could graph this rectangularly, and it's gonna be a positive cosine curve. I know it's dropped down 2, and I know it has an amplitude change, but isn't the shape of that gonna be this? Right? So I'm gonna keep that in the back of my mind too. All right, on which intervals is this function increasing? Now, these are your output values right here. These are your f of thetas. These are your output values. From here to here, to here, to here, to here, aren't those output values going down? So that thing's decreasing. But then starting here, it is increasing. Now, once you think about that cosine curve, doesn't it make sense that the back half of the curve is increasing and the first half is decreasing? That's what cosines do. Sines, it would be different. All right, so I said pi to 2 pi, I was increasing, and 0 to pi, I was decreasing. Good? All right. Identify the maximum and minimum values of the function. Now, it doesn't say where are they, although we could certainly tell that too. It says, how high does it go, how low does it go? Well, again, right here's my chart. What's the highest this thing's gonna go? 2. And the lowest it's gonna go is -6. And that makes perfectly good sense in terms of the rectangular picture here, because you have a midline at -2 and an amplitude of 4. So isn't that exactly what's gonna happen when you graph it rectangularly? What did you do with E? Is it changing faster from here to here, or from here to here? What did you do with that?
Are they the same?
Huh?
Are they the same or not?
Why do you think they're the same?
Because they're both in the, like the same curve, like the same section.
Oh, they're definitely both on this part of the curve, that's for sure. Well, if you look at, here's the thing though about the intervals. This is going up 2, but that is not the same as that. You see what I'm saying? So you're right, these are all changing by 2. The y's are all changing by 2, but the x's are not changing by a constant amount. Anybody have a?
Average rate of change.
Could we find the average rate of change? And the first interval was 0 to pi. So f of pi minus f of 0 over pi minus 0. All right, so that's -6 minus 2. So I got -8 over pi. Is that what you got, Sam?
Yeah.
And then what's our other interval? 2 pi over 3. And pi over 3. So that's -4 minus 0 over pi over 3. You okay with that? So that's what, -4 over pi over 3. So that's -12 over pi. Are they changing the same? Nope. That interval is actually changing faster. And when you look at the graph, and my cosine curve is pathetic, but when you look at it, doesn't it just feel like it's a little less steep on the ends than it is here in the middle? So I'm not sure that's a very like logical, legit reason, but this makes sense to me based on the curve itself. All right, on the interval from pi over 2 to 2 pi over 3, is the distance between f of theta and the origin increasing or decreasing? What did you think on that interval right there? What did you think? Increasing. Because here we're 2 units away, and here we are 4 units away, and that's farther. So even though the curve itself is decreasing, the distance is increasing. All right, you okay? Everybody good? All right, now we have this thing called cracked code. So we're gonna do this together, with each other. I'd like to need the first page, page 5, and total up your true statements. So let's see how many true statements we get. So this is over everything total. True or false? When graphed in a complex plane, the complex number is in the second quadrant. True. -2, 7. That's quadrant 2. That is a true statement. The complex number 4 minus 4i can be expressed in polar form this way. Well, if your number is 4 minus 4i, what's your r, what's your theta? 4 minus 4i. What's your r?
32.
Square root of 32, which is 4 root 2. This angle is how big? Pi over 4, which means theta is 7 pi over 4. So I think that's a true statement. It's got the right r and the right theta. Would you agree? I think that one's true. The polar coordinates can be used to represent a point in the complex plane with a positive real component and a negative imaginary component. Now, do not, you guys, don't let yourselves get confused by this. Where is 6 2 pi over 3? Where is that? Isn't that over here? And if you're a number over here, then isn't your x negative and your y positive? And a complex number is x plus yi. This is the real part. The real part is negative. So this is false. It's way easy, don't get bogged down in all the words. When graphed in the complex plane, negative 8i is on the horizontal axis. It is on the vertical axis. Where is 0 minus 8i? Is it right down here? Remember, the real part is the x part. The imaginary part is the y part. So that's a false. The point on the complex plane described by the polar coordinates represents a real number. What do you think about that one? x is -5. What's the sine of pi? 0. 0. So isn't this -5 plus 0i? Is that a real number? Yeah, because it doesn't have an I. -9 5 pi over 4. Where's that? 5 pi over 4 is here, but with a -9, wouldn't that put me in quadrant 1? 5 pi over 4, this is your angle in your problem, but r is negative. And when r is negative, it flips you. Everything's positive here. So it says we have a positive real and a positive imaginary. That is a true statement. P in the graph, P, is that 3 plus 2i? No, my friends, that's 3 minus 2i. Letter K, all right, K. Is that 3 cosine pi over 4, I sine pi over 4, K? No, where's pi over 4? Quadrant 1. That point is not in quadrant 1, so that's another false. W. W is not, that's another false one. W is not pure imaginary because doesn't W have a real part? W is 1 plus 4i. Pure imaginary would be that. W is 1 plus 4i, so that's false. So how many truths did we get? 1, 2, 3, 4. Did I count right? 4 truths? All right, let's see if we can get through step B. An alternate name for the polar point, this is this. True or false? If it's true, then those angles have to be pi apart, right? Are those angles pi apart? No, they're 2 pi apart, so nope, that's a false. The point this becomes this in rectangular coordinates. So in other words, if you do x equals r cosine and y equals r sine, you should get 0 and -1. That's what it says. So 2 cosine 3 pi over 2. Is that 0? Yeah. What's the cosine of 3 pi over 2? 0. So that's true. What's 2 sine 3 pi over 2? Wouldn't that be -2? Yeah, so no. That's false, because we need it to be -1. It's not, so that's false. Rectangular coordinates mark locations with horizontal and vertical, whereas polar coordinates mark locations with a distance from the origin and an angle. True. That's what they are. Yep. A polar point with a negative angle represents a reflection across the pole. No. A polar coordinate with a negative r represents that, but what does a negative angle mean? It just means you're going this way. You're not reflecting, so that's a false. Do these 2 points represent the same location? Yes. Because when you change the sign on R, you change your angle by pi. But isn't changing by pi the same as changing by 3 pi, 5 pi, and so on? Yep. So that's a true. If a point has Cartesian coordinates so that x is positive and y is negative, then the polar coordinates would theta have to be between 3 pi over 2 and 2 pi. Why not, Leo?
You have a negative R.
You could have a negative r. So if r is positive, that's true, but you could have a negative r, right? And that angle would not be there. So that is a trick one. That's our first, like, really tricky one. But does everyone understand that? On the surface, it looks like the answer is yes, because we're in quadrant 4. But because r can be negative, the angle actually could be in quadrant 2. That one's tricky. The graph described by theta equals 3 pi over 2 has a slope of 0. William's up here shaking his head no, because isn't 3 pi over 2 vertical? And that slope is undefined. So that's a false. A circle given by r equals 10 cosine would be written as x squared plus y squared in rectangular coordinates. Okay, so this is a kind of question where what we talked about yesterday is important. The good news is they tell you it's a circle, and you should recognize that, if they tell you it's a circle. So tell me what that circle looks like. Is it a circle up here, down here, on the right, or on the left? Where is it? On the right? So it looks like this. What's this point out here? Well, just stop right there, never mind. X squared plus y squared equals 25 has a center at the origin. Does that circle have a center at the origin? No, so that's a false. Given a radius r and an angle theta, the x coordinate is given by cosine and the y coordinate is given by sine. Be careful, that's another trick one. You want to say yes, because x is cosine, y is sine, but the answer is no, because x is actually r cosine. It's only cosine if you're in the unit circle and r is 1. So that's another trick one. How many truths did we get? 2? All right, let's get as many as we can on the next page. I know you keep thinking I'm gonna stop, I'm never stopping. All right, set C, number 1. True or false? This we talked about yesterday. Easy, easy, easy. True or false?
True or false?
Why is it false? Because 6 is even, and you're gonna get 12. It's gonna be a very crowded picture. Vocabulary word I haven't used. This is called the polar axis. I've been calling it the horizontal, but this is your polar axis right here. Okay, that's called your polar axis. So, is 4 sine 6 theta arose with polar axis symmetry? No. If it were a cosine, it would, but this one has vertical axis symmetry because it is a sine, right? So that's a false. -3 cosine is a circle to the left of the y-axis with a radius of 3. First of all, is it to the left of the y-axis? Yes. It looks like this. Would you agree with me? What's this point right here? The equation is -3 cosine. So what's this point right here? -3. Which means the radius isn't 3, the radius is actually 1.5. Does that make sense to everybody? The curve given by a minus a sine will touch the pole. Yes. Remember, if those two numbers, a and a, if they're the same, you have a cardioid. And a cardioid has a dent at the pole. If those numbers aren't the same, then you'll either have an interior loop or you'll have a dent somewhere else. Right? We talked about that yesterday. All right, 3:15 is going to be due on Tuesday. And we'll finish this on Tuesday. Whenever I see you again, we'll finish that. All right, so 3:15 is due on Tuesday.